How do we factor x cubed plus 4x squared plus 3x? Now in class I think people may be a little rusty in factoring, but one thing that people do tend to come out of an SOL-driven curriculum in the high school or our MCR courses here on campus, and in both places there are some shortcomings, and I of course mention them when they come up. People still can't do fractions, for example. But factoring is something that I expect that most people have been pretty competent at, and it's kind of my experience that that's the case, but you might need to review it a little bit. So some of this you haven't seen for a while. It should come back, but you might again have to look at some examples and do a little bit of review. Okay, so if f of x equals x cubed plus 4x squared plus 3x, how can we factor that? Is there anything we can factor out of that? Well, yeah, all these terms have x in common, so we can factor out x. And what we get is this, and I know you understand that because you understand the distributive law. And then by hook or by crook, and I'm afraid a lot of times it's by crook, but that's okay. Factoring a trinomial, I don't care how you do it. We see that this factors into x plus 3 times x plus 1. Now whether you were able to get from here to here without a little review, well, a little review will get you there. But we can certainly verify by the distributive law that this times this is this, and of course that this times this is this. So all we're doing in factoring is backwards distributive law. Okay? Now we can graph this function, right? Zeros are at -3 for this one, -1 here, and one of them's a little bit hidden. It doesn't look like the rest of them. It's also 0 if x equals 0. So we have 3 zeros. And we can verify that to the left of -3, all these are negative, so 3 negatives multiply to give you a negative. So it starts from down here, and to the right it starts from up here. So here's our picture, okay? Our y-intercept, incidentally, is also one of our zeros, so that is particularly helpful in figuring out whether we're above or below the axis on a certain interval. Okay? Now, another factoring trick is this. What if we had x to the 4th minus 1? Now, there are various ways you can do this, but I'm going to say, well, x to the 4th is an even power, so if we let u equal x squared, x to the 4th is going to be u squared, because x to the 4th is the square of x squared. So x to the 4th minus 1 is u squared minus 1. And if we remember, and we might not at this point, but that's another thing you need to review some of the special formulas, the difference of two squares. U squared minus 1, u squared is the square of u, 1 is the square of 1, so this is a difference of two squares. So it's going to be this minus this times this plus this. Okay? So it's u minus 1 times u plus 1. Now, u, of course, stands for x squared, so we've got x squared minus 1 times x squared plus 1. And we can factor x squared minus 1 using the same idea, difference of two squares. X minus 1 times x plus 1. And then that's multiplied by your x squared plus 1. Okay? And what are our zeros? Well, x minus 1 is 0, would give us a 0. Well, that occurs if x equals 1. X plus 1 equals 0. We'll solve for x. You get x equals -1. X squared plus 1 equals 0. Solve that for x, and you get x equals plus or minus the square root of -1, which is plus or minus I, which is not a real number. Well, these zeros are not real numbers, so we can't plot them on a set of real coordinate axes. So we just ignore them. We don't totally ignore them. They have a meaning. They tell us a little something. But that's a little deeper than we might need to go in this course. Okay. So our zeros are at 1 and -1. We can verify that if x is to the left of -1, then x to the 4th is bigger than 1. And this is positive. And similarly, if x is bigger than 1. So we're up here, So we come down through here. We do have our y-intercept. If x equals 0, y equals f of x is -1. So the intercept is at 0, -1. So we come down through the 0 at -1, through the y-intercept, back up through the 0 at 1, and we have this really boring looking graph that looks a lot like a parabola. Remember, this is an x to the 4th. It's just a shift of x to the 4th down 1 unit, right? So it's flatter down here than a parabola. Otherwise, it looks a whole lot like, and it's steeper over here than a parabola, but otherwise, it has the kind of general shape of a parabola. Okay? Now, actually, the easier way to graph this would be just by a horizontal or vertical shift of -1, but we're trying to illustrate the more general process that we use in trying to factor a function and find its factors and use those factors to find the zeros and figure out the far left and far right behavior. Now, naturally, this is something you're going to have to read about in your book, okay? Because I can't talk about everything, can't tell you everything in class. Class is not long enough. This is a college course. That's the way things work in a college course, okay? You have to cover a certain amount of material, and I try to give you the seeds, and you make them grow by reading and working the homework. So please do that.